So welcome everyone to the third talk in this series about the 1.5 special report of the Intergovernmental Panel on Climate Change. My name is Kirsten Zickfeld. I am a faculty member at Simon Fraser University in the Department of Geography. So some of you may have attended previous talks in this series. So we had an overview talk. We talked about the science about a month ago. Today we talk about the solutions. Don't miss the last talk in this series, which is going to be on February 28 by Christy Ebi, and it's going to be about the impacts of 1.5 degrees. So today's talk will be on the solutions of 1.5. And our speaker is Yuri Rogel, and there will be respondents. So this will be Mark Jackard, and who will sort of have 15 minutes to present his perspective to Yuri's talk. So Yuri will talk about which path to halting climate change. So let me briefly introduce the speakers. So Dr. Yuri Rogel is a lecturer in climate change and environment at the Grantham Institute at Imperial College London, and a senior research scholar at the International Institute for Applied System Analysis, which is based in Vienna in Austria. And his research mainly aims at informing international climate negotiations with interdisciplinary research linking social and physical sciences. And Yuri has contributed in a leading role to a number of international assessments, including the GAP report of the United Nations Environmental Programme. He was a coordinating lead author on the special report on 1.5, and currently he's also serving as a lead author on the IPCC, on the sixth IPCC report. And sort of the team of authors is in fact gathered in Vancouver this week. So our second speaker will be Mark Jackard, who is a professor in the School of Resource and Environmental Management at Simon Fraser University, and he is an energy economist who has contributed heavily to the design of climate policies here in British Columbia, and is probably known to many of you. And he's also been involved in or contributed to international assessments, also including the reports of the Intergovernmental Panel on Climate Change. And he's involved in the sort of working group 3, which is more the socioeconomic part of the assessment. In the sixth assessment report as well. And he was named a fellow of the Royal Society of Canada in 2009 and British Columbia's Academic of the Year in 2008. So it is my pleasure to welcome our speakers tonight. So we'll start with Yuri, who will talk to us about which path will lead us to 1.5 degrees. Okay, so please let's welcome Yuri.
I might still take some water before. So thank you very much for the kind introduction, Kirsten, and thank you very much for the invitation. My name is Yuri Rogel, and I'm really delighted to be able to provide a talk to you tonight on how we can limit warming to 1.5. I would also like to thank all of you. Thank you for turning up. Lecture is always better if there's people in the room. So, as Kirsten mentioned, I was one of the coordinating lead authors of the IPCC 1.5 degree special report, and this talk will draw heavily on the insights, or will actually present most of the insights of this, or most of the insights presented here will be from that report. I just want to emphasize that I am presenting here in my personal capacity and that I'm not representing the IPCC or the views of the IPCC here, although my talk will be as close as possible to the assessment of the IPCC. So, before we start looking at the solutions of limiting warming to 1.5, I want to take 2 or 3 minutes to step back and ask ourselves, or to go once again over why we are looking interference with the climate system. Now, that is a very ambitious goal. It's also a very vague goal. So, since 1992, governments and negotiators have tried to make this a bit more specific. And after 2 decades, they come up in the Cancun Agreement in 2010 that they've translated the goal of avoiding dangerous anthropogenic interference with the climate system to keeping warming to below 2 degrees. Now, already at that time, there were more than 100 countries that felt that 2 degrees might actually be too high, too much warming. And so, in 2010, they also immediately started with a process of reviewing that goal, which was called the 2013 to 2015 review. That was very creative. And this is basically a 2-year process where policymakers and experts were sitting together, exchanging insights and evidence, and at the end of that process, policymakers decided that 2 degrees was actually not a safe level. It was basically a defense line, and 1 degree would be a much safer level. And this led then to the Paris Agreement in 2015, where the goal was made more stringent from keeping warming to below 2 degrees to holding warming to well below 2 degrees and pursuing to limit it to 1.5. At the same time, that same process, those 3 years that experts and policymakers were sitting together, also showed that there were significant gaps in knowledge, or that the science was not so robust for some of these aspects concerning 1.5. And that is why in Paris there was an invitation to the IPCC to create this 1.5 degree special report. And so there we are. As Kirsten explained, this talk is part of a longer series, and there will be several other talks. I just want to connect this to the other talks. The talk on the impacts of 1.5 degree will basically explain why 1.5, one might want to consider 1.5 rather than 2, or why not. But then Nathan Gillett, I think 2 months ago here, presented the science of 1.5 degrees, and he really shows that the science, or the physical science of how we limit warming to 1.5 degree is quite clear. We know that since pre-industrial times, the Earth has warmed by about 1 degree. We know that historical emissions, or everything that we emitted until today, does not commit us to 1.5, so we can still act and limit warming to 1.5. And it also said that to limit warming to 1.5, we need to limit the total amount of the total amount of carbon dioxide emissions that we put into the atmosphere to a certain limited amount. And this is called the remaining carbon budget. And this is the point, the starting point where I want, this is the point where I want to start to look at solution pathways. So what is this remaining carbon budget? There is a approximately linear relationship between the total amount of carbon dioxide that we put into the atmosphere and the total amount of warming. What does that mean? That has a very clear and simple implication. To limit warming to a certain level, we can emit a certain total amount, a total carbon budget once that carbon budget is exceeded, we should basically stop emitting further CO2 emissions. And what are the implications of this budget, of this carbon budget concept? Well, first, halting warming to any level, be it 1.5, 2, 2.5, or 3, requires that global CO2 emissions are reduced to zero, to net zero. It also has some other very simple implications for pathways. Emitting more in the next decades means that we need to go steeper down afterwards. It's a simple arithmetic based on a finite budget. And finally, if we fail to stay within that budget and we exceed it, not only will the Earth warm more, but the only way to reverse that warming is by actively removing CO2 from the atmosphere. So these are a few key consequences of the concept of a carbon budget. So now, how large is that carbon budget? Here I show you a simple scale from 0 to 1.5. And as I indicated before, we already have seen 1 degree of global warming, and that is the result of our historical emissions of carbon dioxide and also the other greenhouse gases that we put into the atmosphere. That leaves us with half a degree of warming left before we hit the 1.5 degree threshold. Now, unfortunately, not all of that half a degree is reserved for carbon dioxide. We also put other greenhouse gases into the atmosphere, and even if we ramp them down as much as possible, they are still projected to contribute a slightly bit more of warming in the future. And that gives us only a very tiny amount of initial warming that is reserved for carbon dioxide. So how much is this? Well, from 2018 onwards, the remaining carbon budget for limiting warming to 1.5 degree with a 2 out of 3 chance is 420 billion tons of carbon dioxide. And to do that with a 1 out of 2 chance, it would be 580 billion tons. Now, putting this sounds maybe like a big number, but let me put that into context. In 2017, in the year 2017, we emitted around 42 billion tons of carbon dioxide. So that really means that the budget for a 2 out of 3 chance of limiting warming to 1.5 would be exhausted in 10 years of current emissions, and the budget for a 50% chance would be exhausted in roughly 15 years. Or, if you put it differently, and you would actually like to stay within this budget, to limit cumulative emissions to the budget that is consistent with limiting warming to 1.5 with a 2 out of 3 chance, we would need to ramp down emissions linearly from today and reach net zero in 20 years. To do that with a 1 out of 2 chance, 1 out of 2 chance, this would be 30 years. This immediately shows you the enormous challenge implied by a 1.5 degree target. Now, there is some variations, potential variations on those numbers. The first variation that is that we don't know exactly what we will be able to achieve with non-CO2 emission reductions. And this can increase or decrease these numbers that are mentioned above, mentioned earlier, by plus minus 250 billion tons of carbon dioxide. And then there is also more uncertainty about the exact response of how the climate system would react to particularly the aerosols, or the small particulate matter that we put also into the atmosphere. And that actually has a much larger uncertainty of plus minus 400 billion tons. So despite these large uncertainties, the one key message is clear, and that is that this budget is really small, and it kind of implies net zero emissions by mid-century for limiting warming to 1.5. Now, compared to the previous assessment of the IPCC that was published in 2013, there is both good news and there is bad news. The good news is that improvements in our understanding and methodological understanding have resulted that if we compare like with like, our best estimate of a carbon budget to limit warming to 1.5 is around 300 billion tons of CO2 larger than was estimated at the time of the AR5. So that, good news, we have slightly bit more space for limiting warming to 1.5. However, at the same time, better understanding of unrepresented Earth system feedbacks like the thawing of permafrost have resulted in understanding that these budgets that I mentioned above would actually be decreased by another 100 billion tons of CO2. So also this last, so while it is slightly better or slightly more positive than at the time of the AR5, there is definitely no reason for complacency. So now that we know the geophysical kind of limits within which we have to within which we have to move to limit warming to 1.5, the question is, of course, how do we translate this geophysical budget into societal transformation? How do we transform our society so that we stay within this budget? And that question one tries to, or scientists try to answer by using models. And the type of models that they use are called integrated assessment models. These are models that try to link different disciplines or insights of different disciplines to provide integrated paths of how society can develop in the future. And here I give you a short schematic of such a model. You don't have to look at every arrow in here. I will highlight just a couple of key components of such an integrated assessment model. For example, here in this blue box, this is a representation of the energy system, of how we produce the energy that we use here to switch on the lights, to make this microphone work, and so on. Another part of these integrated assessment models are land use models. That kind of model, how we produce our food, how we get the wood products that we use in building or also for energy. There is a representation of the climate system, which then can determine what that implies for global warming. And these are kind of the core components of such an integrated assessment model. These are fed with socioeconomic assumptions about how GDP, how the economy will evolve, how population will evolve, how urbanization will evolve. And then most importantly, they are constrained or they are limited by a certain climate constraint. And for example, in this case, one can ask these models whether they can provide solutions that limit the total carbon budget or the total amount of emissions that are produced over the century to a certain carbon budget. And this is really how these geophysical insights of how much emissions we can still emit are translated into transformation pathways. So within the 1.5 degree report, we have looked at this literature and we've collected many of those pathways from the literature and we put them in a database and then we group them based on their success of limiting warming to 1.5. And so now what I'm now going to present are the general characteristics of all those pathways that limit warming to 1.5. First of all, we start with global carbon dioxide emissions. And here what you see in this blue area is the evolution of global carbon dioxide emissions over time. And there are a few key characteristics here that that I want to highlight. The first characteristics is that there is a really robust decline in the first decade, so after 2020. All these pathways, they decline by -40 to -60% in 2030 relative to 2010 levels. The second key characteristic is that by mid-century, all these pathways reach net zero. Now, you could already deduce that from the carbon budget and from the simple calculation that I did earlier, that this is actually a requirement for these pathways to be consistent with 1.5. And the last characteristic is that in the second half of the century, all these pathways are actively removing carbon dioxide from the atmosphere. The reason for this is because they compensate for still ongoing warming of non-CO2 forces, for example, from nitrous oxide, or because they are trying to peak and decline temperatures. So they don't stabilize temperatures at 1.5, but they try to slowly decline temperatures again after having peaked. The report, so all these pathways limit the maximum amount of warming relatively close to 1.5. But the report also identified a set of pathways that that first exceed 1.5, so basically miss the 1.5 degree target, and later try to make up for it. And these are called high overshoot pathways. And the characteristics of these are slightly different. They see that they also see a robust decline in global emissions, but this decline is delayed by a decade. It only starts in 2030. They also reach, however, net zero emissions by mid-century, but in the second half of the century, they see much deeper carbon dioxide or much more carbon dioxide removal to make up for the excess of emissions that they put into the atmosphere over the next decades. And then finally, we are not just emitting carbon dioxide, we are also emitting other greenhouse gases or other climate forces. And here you can see one selection of these other climate forces, methane, black carbon, and nitrous oxide. And what you can see here is that all these other climate forces are also reduced or strongly reduced, but they do not reach zero. And the reason why they are not reduced to zero is that there are some activities that are core to our societies, like food production, that are sources of these greenhouse gases. And at this point in time, we have not yet identified measures that can eliminate those emissions from those activities. At the same time, you can also see that, for example, for nitrous oxide, in some cases, in some futures, nitrous oxide even are further increasing. And this is actually linked to how much bioenergy one assumes is used in the future. The fertilizer that is used to produce this bioenergy results in actually increasing nitrous oxide emissions in the future. So already here you can see that despite the clear characteristics of all these pathways, there is also some variation between them. And I will come back to this variation later, because this is one of the key insights of the report. Now, until now, we have looked at what emissions are doing. So the question is, how do we achieve these emission reductions? And the 1.5 degree report in the IPCC in general is really well known to have very clear and transparent messages, and this is one of them. Limiting warming to 1.5 would require rapid, far-reaching changes on an unprecedented scale. Now, to be honest, I don't think it's so clear what that means. But the IPCC, with each of the words that are in bold here, actually means something very specific. With rapid, it means that changes need to happen in the next decade. With far-reaching, it means that changes need to happen in all systems. We need to change the way that we produce energy. We need to change the way in which we produce food or we produce wood for our construction. We need to change the ways in which we transport ourselves, in which we build our houses, in which we design our cities, and we need to change the ways in which we produce our products. That means far-reaching. And ultimately, on an unprecedented scale, it means that stringent actions need to occur everywhere. Some of the actions that are implied by these very stringent mitigation pathways, or the pace of these actions, has been observed in the past in certain contexts and for certain sectors. However, now this kind of pace of change needs to be multiplied in all sectors and all areas. So we really need to see stringent actions everywhere. So far-reaching changes on an unprecedented scale. Now, let's have a look at what this means for the energy system. How would one go about decarbonizing the energy system? And the report here identified 4 key components of decarbonizing the energy system. The first of which is to improve energy efficiency. By improving energy efficiency, you reduce the size of the energy system, you reduce the total amount of energy that one has to produce in order to meet all the services that we want. We want lighting, we want heating, we want transport. But with energy efficiency, the demand for this can be limited, or the energy demand for this can be limited. The second step would be to electrify energy end use. That means to electrify mobility, to electrify appliances in housing, for example, cooking, heating, and so on, or also some industrial processes. Now, electrifying end-use appliances only makes sense, of course, if the electricity that you're producing is also decarbonized, and therefore a key aspect that cannot be seen separate from electrifying end use is to decarbonize the power sector. For example, in those pathways that limit warming to 1.5, we see a carbon intensity of electricity close to 0 by mid-century, or even negative. And a negative carbon intensity, that means that for each unit of electricity that we produce, carbon dioxide has been actively removed from the atmosphere and actually stored somewhere underground. And I will come back later to how that actually happens. And then finally, there is always some areas where it's really hard to electrify. And there, one should substitute residual fossil fuel use with low carbon alternatives. And one of those is, for example, to substitute with sustainable bio-based fuels for transport. Now, where does this transformation end up? And let's have a look at key transformations in the energy sector. And this is again a very busy graph where you can see the total amount of primary energy by fuel type, but I will try to make it slightly easier for you. Here on the right-hand side, you see the renewables, and you see that renewables are scaled up robustly across all pathways. They are increased and they meet around 15% of primary energy in 2020. That share is doubled by 2030, and that is doubled once more by 2050. At the same time, at the other side of the graph, fossil fuels show a clear decline. But there is some variation across the different types of fossil fuels. Coal sees a strong phase out in any scenario and in any sector. That is kind of a done deal. For oil also declines, or oil use also declines, but there is still quite some oil use by mid-century. For gas, the image or the picture is very diverse. There are some scenarios in which gas use is strongly declined, and in a few scenarios, gas use even increases slightly until the middle of the century. Now, it is not, this does not come without consequences. Increased gas use is only possible if we assume that carbon capture and storage, that basically that means that we capture the CO2 that is produced by combustion of this natural gas, that this is scaled up efficiently and effectively. And so only under that assumption, we see gas use further increase until mid-century. Of course, transforming the energy system needs investment. And because this is a global energy system, it needs significant investment. What you can see here is the total average annual investments between 2016 and 2050 for a 4-degree pathway, totally at the left, and then going incrementally to more stringent pathways to the right. And what you can see is that the difference in total investments between a 4-degree world and a 1.5-degree world would be $830 billion of additional investment. Now, of course, this is larger investments, but this buys you a zero-carbon energy system by mid-century in which you have halted climate change. So you are doing this investment with a reason. It will also buy you cleaner air and less environmental degradation. What these large bars, however, kind of do not really clearly show is that there is a huge shift in investments. The investments in low-carbon energy and in energy efficiency have to scale by a factor 6 between 2050 and 2050. So that really means that there is a lot of investments that need to be redirected from fossil fuels into renewables and low-energy options. Now, just to give you a sense of what these numbers actually mean, $813 billion is, of course, a huge amount, and that is the additional investment. However, if you compare that to the amount of dollars that we spend each year paying for energy, it is actually an order of magnitude smaller. So putting this into context of the entire economy and the entire economy that the energy system represents, this becomes a much more understandable number. Then the last aspect of 1.5 degree emission pathways that I want to highlight is the use of carbon dioxide removal. Carbon dioxide removal is an activity. It actually means that we are actively removing carbon dioxide from the atmosphere with our activities. And there are several ways of doing this, some of which we are very familiar, and others might look a bit more strange. For example, here on the right-hand side, there is one way that you're probably all familiar with, that is afforestation and reforestation. By planting trees, carbon is sequestered in the forest. On the left-hand side, you see a more technological way, which is called bioenergy with carbon capture and storage, or abbreviated, often referred to as BECCS. And what does that method entail? That method entails that you grow plants, and those plants, while growing, they absorb CO2, and that plant matter is then transformed into another source of energy, be it electricity or ethanol or anything else. And during that process, the CO2 that is produced is captured and sequestered under the ground. So as you can see, this is a much more technologically advanced way of doing carbon dioxide removal. Now, all the 1.5 degree pathways that we were able to identify in the scientific literature use carbon dioxide removal to some degree, in the range of 100 to 1,000 billion tons of carbon dioxide removal over the 21st century. And they do that for two reasons. The first reason is to offset residual emissions in other sectors. Some sectors, like aviation or freight transport, are really hard to decarbonize. And therefore, carbon dioxide removal can kind of compensate for these residual emissions elsewhere. For the climate system, this doesn't really matter. It's the net emissions that matter for climate change. The other reason why these scenarios use carbon dioxide removal is to achieve net negative emissions and to basically reverse or to peak and decline temperatures after having peaked slightly above 1.5 degrees. There is one big but yet, however, and this is that that the report has also identified that CDR deployment of several hundreds of gigatons of CO2 is subject to multiple feasibility and sustainability constraints. And as you can see, the scenarios range in their deployment between 100 and 1,000. So somewhere in that range, these concerns, these feasibility concerns, really start to play. And to understand this better, the report has tried to highlight this in a very particular way. What I showed you until now were the general characteristics of a whole group of pathways. Now, within that group of pathways, there is still a lot of variation, and what we did with the author team of the report is to select 4 illustrative pathways that can illustrate how not all pathways are created equal. What I show you here are 4 pathways which we very creatively called P1, P2, P3, and then P4. And 3 of those, P1 until P3, are pathways that limit warming to 1.5, and P4 is a pathway that has an overshoot, so that first misses 1.5 and later tries to make up for it. Then what is the difference between pathways P1 to P2, P2 and P3? Is the underlying socioeconomic and technological assumptions, the underlying strategies also by which one tries to achieve a certain emission outcome. And what these plots show is basically a breakdown of global CO2 emissions. The gray areas here show emissions of fossil fuel and industry. The brown areas show the emissions of agriculture, forestry, and land use. And the yellow areas show the carbon dioxide removal with BECCS, the bioenergy, with carbon capture and storage. And what you can immediately see is that these different pathways use these different measures to a very different degree. For example, P3, which is a pathway that kind of continues historical experience in both socioeconomic development and in technological development, you can see that there is a significant amount of BECCS of the yellow area that appears in the second half of the century. If in contrast you look at P1 and P2, which are two scenarios where energy efficiency and sustainable lifestyles are strongly emphasized, you can see that the reliance and the use of these negative emissions is strongly reduced. On the contrary, if you then look at P4, which is a scenario that where with relatively low energy demand reductions and with a continued use of fossil fuels, you can see that one really relies on massive amounts of carbon dioxide removal, which come close to that higher end of the range that I mentioned in my previous slide. So which definitely start to ring some of the alarm bells in terms of feasibility and sustainability constraints. So if you compare P1 with P4, you can see that demand-side measures like improving energy intensity or sustainable diets, as well as early reductions in, of carbon dioxide, reduce the need for carbon dioxide removal. And this really leads me to the next slide, where I want to show how different strategies can still lead to the same climate outcome. Again, a slightly complicated and busy slide, but what this slide shows is the total amount of energy used in 2030, 2050, and 2010 for the four scenarios that I showed on the previous slide and an additional one. And I would like you to focus here on P1, P2, P3, which are three scenarios that basically limit warming to 1.5. They all reach pretty much the same climate outcome. And the colors in each of these bars, they show different types of energy used. And there are three observations that I want to make here. Within these three scenarios, P1, P2, and P3, you can immediately see that the size of the bars differs quite a lot. So the total amount of energy that these different scenarios use varies quite a bit. The second observation I would like to share with you is that also the colors within these bars are quite different between them. For example, in P3, you can see large chunks of green, which represents bioenergy. Bioenergy production needs land and can therefore come into conflict with other uses of land, for example, with food production. And then ultimately, for the really sharp eye or the far-sighted, in the P1 scenario, you can see that the P1 scenario makes the explicit assumption not to use any carbon capture and storage. So that scenario basically tries to understand how we can limit warming to 1.5, assuming that carbon capture and storage, so that means the capturing, the compressing, the transporting, and the sequestering of carbon underground, does not scale up as expected. So the variation and the variety in these scenarios are really important for my next point, and that is that mitigation choices matter for sustainable development. Many of the mitigation measures, or many of the mitigation measures that are deployed in those scenarios, they interact with sustainable development. For example, I gave the example earlier of bioenergy. Bioenergy needs land. That land can potentially not be used anymore for food production, which can result in in a rise in food price, which then is not so beneficial for poor populations that have limited food security. So the good thing, however, is that the report was able to identify more synergies between climate change mitigation than trade-offs, and in particular demand-side measures. So these are measures where we change our behavior, where we shift to behavior that uses less material, less energy, or less land. particularly these measures are able to maximize synergies with sustainable development. Also there where trade-offs were identified, and I gave the example of rising food prices. Also there the report highlights that these trade-offs do not have to materialize. If we put in place right or smart policies, one can shield, for example, the poor against food prices by providing a food subsidy. So the main point I want to make here is that choices about which mitigation strategy you pursue, they matter. They matter for other objectives that we set ourselves as a society, be it clean air, be it food security, water security, and so on. So that really means that we need to be smart and critical about which measures we put in place to limit warming to 1.5 or basically to any level. Now I will try to answer a question that probably all of you have been asking yourself. Is this feasible? It's a very good question. And also here the IPCC came up with a very clear answer, is we can't say. So basically what we did, what the report was able to do is the report was able to identify several dimensions, several tick boxes that we have to tick in order for these pathways to become feasible. And some of those tick boxes, we as scientists, we can easily tick. For example, if you look here at the left-hand side, where it's written geophysical feasibility, there we need to answer the question whether we can still, within the laws of physics and chemistry, limit warming to 1.5. And yes, Nathan Gillett in the last lecture here showed, yes, we can still do this. So that's a tick box from the scientific side. Then the environmental feasibility or the technological feasibility. Do we have the technologies and can they scale sufficiently at sufficient pace to make those pathways happen? And also there, we have the evidence, we have the scientific evidence or the historical evidence that these pathways or that these technologies could indeed scale at the pace required. So also there, as scientists, we can kind of confidently tick tick these boxes. But then we come in an area where the ticking of boxes is not a scientific question anymore. The first is the economic feasibility. Also there still, as I presented earlier, we can understand that in the economic system that we have now, it would be quite feasible to achieve those pathways. But then there are two dimensions, the social cultural feasibility, basically asking the question whether we want to change our behavior, whether we want to change some of our habits, are not boxes that we as scientists can tick, but these are boxes that you have to take home and that you have to ask your policymakers, that you have to ask your friends, yourself, whether you want to tick that box. And also the institutional feasibility is whether we have the institutions, whether we can politically change or make the necessary change or the change required to make those transformations to a low-carbon world. And obviously that is, again, not a box that we as scientists can tick. So, knowing how a 1.5 degree world would look like, the IPCC report also looked at whether we are on track or not. So, this gives us a small reality check. I want to quickly remind that all the pathways that we saw in that limit warming to 1.5 saw strong reductions after 2020 and limited emissions in 2030, already significantly below today's levels. Well, if we look at the national pledges, the pledges that countries have put forward in the climate change negotiations of the United Nations Framework Convention on Climate Change, if we add all those up, we see that emissions would stay between today and 2030 would stay roughly constant or increase slightly. And even worse, if we look at what countries have currently implemented in terms of legislation, they would even not achieve what they have pledged. And this contrasts very strongly with the almost halving of emissions by 2030 that would be compatible with limiting warming to 1.5. So the question whether we are on track or not to achieve a 1.5 degree pathway, we can very confidently answer that we are not on track. So In my final slide, I quickly want to reflect on what the report tells us on what we should do to limit warming to 1.5 or 2. And I think the key message here is that we need to act. And we need to act in 4 different ways. The first way in which we have to act is that we have to act now. We have to start implementing policies that reduce emissions, not only to limit warming to 1.5, but also to gain experience, to start to understand how these policies and how these measures work, that if we are unlucky and some of those are not deployed the way we expect, we might end up with 2 degrees of warming and stabilize warming at that level. The second point is that we have to act everywhere. I highlighted at the beginning that we need changes in all systems, and that is because we need to reach net zero global emissions. So there is no sector, or there is no area of society really that can pass the buck to somewhere else. We need to find ways of reducing emissions in each part of society, in each activity that we undertake. The third point is that we have to act thoughtfully. Climate change is not the only thing we care about as a society. As I said, we care about food security, water security, we care about biodiversity. So we don't just want to deforest the Amazon to put bioenergy plantations. So it is really important that we develop strategies that maximize synergies with other objectives that we have as a society. And then finally, we have to act jointly. It is really clear from the literature on scenarios that acting in isolation, either internationally, so at the national level, or also subnationally between local or subnational or national governments, also working together with civil society or with business, is absolutely necessary to achieve the stringent mitigation pathways, or even just a net zero global emission outcome that is really required to limit warming to any level. So, and with that, I would just want to still invite you to, if you're interested, please go to the website, download the report. There is a lot of material available. And for those students that would like to dive a bit deeper into what all these scenarios mean, actually all these scenarios, they are available on an online portal where you can even have a dump download of all these scenarios, and you can play with it and you can explore this further to try and better understand what can be done to limit warming to 1.5. And with that, I would like to thank you for your attention, and we will be ready to answer any questions later. Thank you very much. That's confusing.
So our next speaker will be Mark Jacquard.
Thanks, Kirsten. And thanks, Yuri, for a wonderful talk. I'm one of those people who has kept meaning to go on the website and start reading that long report. And well, now that I've heard your talk, I don't know, but I'll make my students do it, so you can find out that way. So Kirsten asked me to be the respondent, and what I did in looking at Yuri's slides is think about those last 3 or 4 slides that he had, which were saying, okay, here's what we know from the scientists about the numbers and what we need to do, and the realm of my life as an energy economist and someone who works a fair bit on the policy side and a lot on human behavior, and so a lot of research on when we're told that we should all act, how people translate that or don't translate it or are not able to translate it into what they would do as individuals who are consumers having a certain lifestyle, or as citizens who are thinking about which politicians they ought to support and what they should do. And it's very messy out there, and I know Yuri would agree with me that one can end with a talk like his and still say, but wait a minute, what actually do I do? Act in every sector, on everything, at all times? What does that mean? So in just 15 minutes, I'm going to have a very few slides that follow up from that. But even to do that, my first couple of slides sort of remind us of why this is so difficult. And so, let's see if they're working. Yes. So why is greenhouse gas reduction so difficult? Now, I always think it's important to put this out there first, because what you're going to see in my talk is I'm going to be a bit more strategic. I'm going to say, sure, we should act everywhere, on all things at all times, in all sectors, but research about humans and also the economics and technological questions are teaching us slowly that some things may be strategically easier to move on, or the degree of difficulty on everything is high, and some are even higher. So think of this as you're all trying to be Olympic athletes, and I'm trying to find the ones that have the least high degree of difficulty in order to increase our chances of moving quickly. So remember then, why is it such a problem? So first of all, remember, it's a global collective action problem. So you might often hear about, well, why aren't we reducing emissions? Well, it's a global problem. And so if it's a global problem, then you need a governance institution. So with acid rain, where it was in one country or maybe between two countries or several European countries, and they had some kind of governance institution, or local air pollution, you have some way of setting rules, of making things happen. Globally, we're very weak. We're very weak in institutions, and we're very bad at diplomacy. And so just for example, rich and poor countries can't agree on a fair sharing of the costs. And also, that means, though, that if you can't agree on the sharing and you can't come to some kind of agreement, it's really hard for anyone to act. Because as soon as you do act, you say, oh, is everyone else free riding on us? And I'll get to the domestic politics in a minute, but it's really hard for one country to act. There are costs to acting. Does it affect its trade abilities, its ability to do well in trade? What else does it affect? And that's why I might even end up saying, oh, you may need to act more quickly first on domestic things like electricity production or your own transportation sector, and it may be more difficult with internationally traded goods like steel, cement, and aluminum. And so already I'm starting to try to show you how degree of difficulty is going to play into how we act strategically on this. Now, what if greenhouse gases and the solution of it was just a national problem? It wasn't a global problem. So what if Canada reduced its emissions, we wouldn't have climate change? The Americans would have climate change, but we wouldn't. Even if it was just a domestic problem, like a city with local air pollution, it would still be very problematic. Because while we know, and what Yuri was saying, that when you think about the transition of an energy system, which is what I work on, if you move it gradually as you're renewing cars, upgrading buildings and factories, the cost of deep decarbonization, that's the term I'll use, is reasonable. And I'll even give some numbers about that in a minute. But you have to bear some costs up front, and the benefits are down the road. Well, that's totally out of sync with our 4-year electoral cycle. So you're going to need political leadership, right? Because it's going to have to be a politician that does it and knows they will pay a political cost. But that makes it incumbent on, well, this is what I say to my students. I say, it's not good enough for us to say, look how stupid the politician is. We have to be able to design policies that a politician could do that would show leadership and do the right thing and get them reelected. And that's really difficult. And that's what we should demand of ourselves, though, when we're or any of us as citizens. Sort of like, why isn't that politician doing X? You should be able, you have enough smarts to understand how this would blow up on someone in a political process. And we have lots of examples of all of that happening right now in Canada today on climate policy, and maybe we'll get to some of that in question period. Because I can talk for a very long time, so I had to cut that out. Fossil fuels are incumbent, right? It's an 80% global, 85% global fossil fuel energy system that we humans have developed over the last 250 years. So you might say, well, that gives it an advantage economically, but it's not just economically. It means whole regions of the planet have their economies based on that. It also means that large corporations are earning their profits from that, and they have powers that can help them influence the political process. So you've got a really huge challenge right there. And also, faking it policies. So not everybody out there is a climate policy expert. So I've spent a lot of time trying to say you got to have compulsory policies. Like, what's that? It's got to be regulations or pricing. So I chant that over and over again. It's nice, but it's not Rick Mercer commercials. And that's what we did to try to achieve Kyoto, plus a voluntary challenge with industry. So faking, and so Stephen Harper, defeated Stéphane Dion 10 years ago by saying he's going to destroy the economy with carbon taxes. I'll do it a different way. I'll do it with regulations. I happen to think we should be using regulations, and we are, and I've helped design them, and we can do it. But he can also say, oh, now I'll start a negotiation process. Oops, 10 years have gone by. Still never really got there. So that's a faking it. There's so much faking it policy out there. We need to be able to detect that. Now, then we make greenhouse gas reduction extra difficult. Partly with the deliberate delay tactics that I've just talked about related to regions or corporations or individuals who just find it inconvenient or disadvantageous or think it would be bad to act on this issue of greenhouse gas reduction. So the argument that climate science is a hoax, or at best it's too uncertain, and we hear that a lot from politicians, less so in Canada than we used to, although it still comes back. This fossil fuel project is okay. It's okay because, well, we won't stop using oil tomorrow, or it's within I've even heard it's within the carbon budget. Those are my colleagues in Alberta, so we argue about that. So that means it's within the 2 degree, I don't know, we haven't started yet arguing about the 1.5 degree carbon budget. We need the jobs and taxes from this project. We don't yet have alternative technologies or fuels. This project is for export, so we're helping poorer countries. That's why we're doing it. And there's no point reducing emissions till the Chinese do. Oh, they are reducing emissions? Oh, well, until they really reduce emissions. Our fossil fuel is ethical because we're not terrorists. No. And so these are familiar to all of you. They're in the ads that we're inundated with all the time and on radio talk shows. So, but we also make it extra difficult with some other, I'll call them inadvertent or well-meaning delay tactics. And that's by making the problem bigger than it really is and not focusing strategically. And this is a plug for a book that I've just finished, in which I explain all this stuff, but I obviously won't, I'm going to go fast over it right here. The book is called Dueling Delusions, because I'm saying just as there are delusions about climate science, there can be delusions about all the things we absolutely have to do. There are things that are really good if we did them, eating less meat, consuming less, preserving all of the rainforests if we could. There's a huge list. But more equity. But what are the things that get us with this problem as fast as we can? Because we don't really have time to be pushing the effort where it's not going to, or we're deflecting on that effort. And that's why I call them inadvertent. So people hitch their agendas and wishful beliefs to the greenhouse gas effort, which can make it seem extra complex and difficult, that we have to do all these things all the time. And I'm going to argue that there's just a couple of areas that we really need to focus on where we're already, we know the technologies, we know the costs, we have jurisdictions that have done it, including our own in electricity, and what is it? What can we do to make that happen? So that's the last few slides I've got here. So people will say energy efficiency is critical and profitable. I support, of course, pushing on energy efficiency. But often energy efficiency is presented as, let's do that first. And for 30 years, I've been involved in analyses about energy efficiency that get swamped by other kinds of things, something called a rebound effect, where people still use more energy, or where it's actually more difficult than we think to do energy efficiency. Behavioral change is essential. We should be changing our behavior. Is it essential? We should pursue carbon neutrality. There's another one. Renewables are cheaper than fossil fuels. So when I hear that, and I'm in a meeting with a cabinet minister, and I'm saying to the cabinet minister, we got to regulate how we do electricity or put a price on it. And if the environmentalist is saying, no, renewables are cheaper, the cabinet minister says, oh, so I don't have to put a price on it or regulate. Renewables are going to win anyway, so we can just delay the policy. I've been in discussions like that 20 years ago and 2 years ago. So we must abolish capitalism. Lots of you might want to do that. Fine. And go for it. But please work on the other stuff too. We should achieve global equity. We must save and so on and so forth. Stop flying, stop eating meat. So I may be rubbing some people there. Good, you'll want to buy my book. So here, now my last few slides, why greenhouse gas reduction is simple. So I know that there's all those elements that Yuri brought up, and I'm not trying to belittle them or delegitimize them. They are all important. I'm trying to figure out, though, how in this degree of difficulty Olympics game, we can have the best chance of success. And just as I give you that example with industry, that it's really hard to work on industry that's globally traded when it's a global good, it means that there are other sectors where one might work on and move faster. And that can give us a feeling of success with this problem. And that can spill over. So this is all much more to do with political and psychological dynamic. What I learned is I was on the IPCC 20 years ago. I stopped doing it for a while because I thought, how many more modeling studies I do of what needs to happen? I need to start, as an economist on the engineering side, I need to start learning from psychologists, political scientists and theorists, and that's what I've tried to bring into these few comments here. Technology, energy, and perhaps some behavioral change is a deep decarbonization, and I'm distinguishing actions, the things we do, from the policies that drive that action. So we need to look at these things by degree of difficulty. Electricity generation and transportation are more domestic industries, and therefore it's more possible for a leader country to work on those and be able to do that politically. It's not easy. It's less difficult. And also, as I'm going to point out, and that's the next slide I have. I'll show it right here. And we have the available technologies for that. So this slide here, I've actually forget the source, is showing a pathway that's still heading on the 4 degrees and higher pathway. And so I think it's taken from the IPCC, but not this report, about where would the emissions come from? And so first of all, more and more of the emissions are from developing countries, so the bigger pie, non-OECD, and the numbers will all add up to what that total forecast is in 10 to 9 metric tons. And if you look on the right pie and on the right half of that pie, that's transport, electricity, natural gas, and electricity of coal. That's half of the emissions in the developing world are from those 2 sectors I just pointed out. And more than half in the richer countries are from those 2 sectors. So this is the energy-related one. So this is not land use change, and the other ones, which you saw as that smaller section on Yuri's graph. So now the policies. So policies are efforts by governments to cause those actions by firms and households, right? And I'm going to focus on electricity and transportation. They need to be compulsory. So that was my point about the Rick Mercer commercials. They change the rules and incentives in mostly what are market economies, or wherever there is a part of your economy that's planned, fine, do that. And they should be assessed by political degree of difficulty. Now, here's one. We sort of bought into this in Canada that you have to do carbon pricing. That's not actually true. If you took any economist and hooked them up to a lie detector test, they would have to admit you can do it entirely by regulations. And we've dealt with lots of other environmental challenges in that way. They prefer pricing, and in my heart, I prefer pricing because I'm an economist, because it's more likely to cost us less. So that's more money for hospitals and schools and so on, and may make the total cost lower, so it's easier to motivate people to do it. But it's very difficult politically. And I've been saying that with some other economists who are listening to political scientists for 15 years. And that's why I would tell Stéphane Dion when he did ask me, I said, do not run an election on a carbon tax. You will lose for sure. We'll get a different government who won't do anything on climate. So in fact, you're being economically inefficient to run on carbon taxes. And so what you can do is you can regulate. Now, people say, economists will say, well, some economists will say, well, regulations are really inefficient. They cost a lot. But it's not always true. You can actually design them so they have a lot of the flexibility and competition that are just like carbon taxes. And the two examples I'll give is you can say to the electric sector, you got to phase out coal plants. And then use all the competition you want to figure out what replaces it, whether it's wind or solar, and whether it's large scale, small scale. Is it nuclear power in some cases? Is it carbon capture and storage with natural gas or coal? Let the market figure that out with some regulations for other environmental impacts, of course, but don't say it's got to be this technology or that technology. That's why economists object to pricing. And another one would be, so in British Columbia, since January 2007, we have a clean electricity requirement. And I wonder how many of you knew about that policy? Raise your hand if you knew that policy. Okay. Well, these are all my students down here. My students and 4 other people. All right. And they would fail if they didn't know that. So, and that's amazing because our carbon tax got all the news. The carbon tax caused a huge political battle in British Columbia, and by our modeling, which was the model the government used, it does just a small contribution, 4 megatons to the year 2020. Whereas the electricity's prevented 2 coal plants, an extra natural gas plant, works out to about 15 to 18 megatons. Look at the difference in those 2 policies. How much objection was there to the electricity policy? Rachel Notley put in a carbon tax. I don't know, the fossil fuel industry talked her into it, and some economists. And our modeling shows that, which is the same model that her government uses, shows that it does no more than 3 to 4% of the reductions caused by her climate plan. She's also put in a policy to phase out coal plants. That's huge. She's put in a policy to have methane regulations. That's huge. And a sort of regulation with pricing for industry, which has a significant effect. Finally, here in British Columbia, and I've been ranting for it for a long time, we've copied California with a ZEV, a zero-emission vehicle standard. Now, it should be way more stringent than they put it in. Maybe I can talk about that later. But it's a really good start. So we're following Quebec and going beyond what Quebec is doing, following California, and potentially going beyond. And then there's a whole issue about leading jurisdictions. Every year that we meet the Framework Convention on Climate Change and try to voluntarily come to some agreement. I don't think that's how we're going to get there if we succeed at all. I think that's a path to continued failure. It's going to have to be leading jurisdictions putting tariffs on imports and then trying to find other leading jurisdictions who will do the same. That's the reality of humanity and selfishness and trading. But, that's a big discussion as well. So there's a schema of policies, the non-compulsory, the compulsory I talked about, the regulations and emissions pricing, carbon tax we have in BC, cap and trade, Ontario had for a year and then Doug Ford got rid of it. California has it, Quebec belongs to it. Conventional regulations should not be confused with flexible regulations, and that's my point. And so I'm going to, here's a greater description of them, which I will talk about if we come up with that. I'm going to stop right there, and thank you. Because I want to have time for a discussion, and so I think that's a good place to stop. Thank you very much for your attention.
So we have about half an hour for discussion. So there's a microphone right here in the left-hand aisle, and also Nastenka will be passing around another microphone. So raise your hand or walk up to the mic there in the back. And also I'd like to remind the online audience that you can submit questions online, and they will be read out loud. So please go ahead.
My question is primarily for Mark Carter. Very simple question. How would you generally rate the environmental policies that the NDP Green government are bringing in, especially in terms of things like Site C and the current pipeline dispute and so on, and where would you like to see us go?
All right, and I just want to say ahead of time, this is a British Columbia audience, and so yes to questions to me, but let's also remember as well, I just want to say it in advance about this fascinating topic that we've got right here, and a resource of Yuri, who's very well known internationally, by the way, with his work. In terms of BC policy, I thought you were going to say climate policy that we just put in, as opposed to Site C or pipelines. I can go into those. I think the climate policy that the government just put together is fantastic. And it's not nearly as good as I want, or as stringent as I want, but it's fantastic for what we can do. And the reason is, well, we've already done, Gordon Campbell did the things in electricity that we needed to do. So we have a zero-emission electricity system. So now we can do the things that were on Yuri's diagram about electrifying our economy. Our buildings, industry, and transportation is the one where suddenly we're getting this huge opportunity. And we're getting that opportunity as well because of developing countries, China, realizing that air quality is important, and suddenly electric cars are looking good everywhere. So if we can convert our transportation system rapidly, I would have liked them to have done the ZEV, to have a much higher standard for 2025. It could have been 25% just for that. Norway is a good model to follow. And then the only other, we have a low carbon fuel standard. It's another flex reg that would force in some sustainable biofuels, as Yuri was talking about, especially in our trucking sector. But otherwise, I think that policy is very good. Site C is a decision that was not part of a climate policy, but was, okay, this is there, what's the best thing to do going forward? And pipelines, if you think of Yuri's talk, and he showed the 1.5, and even when I've seen it with the 2 line, coal goes down, oil goes down, natural gas is uncertain. So as a researcher who tries to be evidence-based, it's not as easy for me to say that we shouldn't do and export natural gas. I don't shout it to the rooftops that we should do it, but I'm not able, objectively, to say we shouldn't be doing it. It depends how it maps out according to what Yuri had there.
I'm from Alberta, and I don't represent Rachel Notley. I'm from Alberta. I'm from Alberta province.
Yeah.
All right. Okay.
Where's that?
Okay. And so in that province, oil sand is the key economic driver. So we know the challenge of economy and politics. And given that Alberta will keep producing oil sands to export to different places of the world, but in Canada, what can we do to at least try not to, maybe not able to achieve the 1.5 degrees Celsius in 10, 20 years, but what else can we do effectively to bring down the carbon emissions? We see the CO2 concentration is rising every year, consistently 1.5 parts per million without fail for the last 50 years, and it doesn't seem going to slow down. So how can we achieve the 1.5 degrees Celsius limit?
So we have emissions falling in Ontario, dramatic fall because they put in a coal phase-out policy. So I didn't know if you meant for Alberta or the country, or the planet, but in the case of what I'm saying is the federal government should put in a zero-emission vehicle standard and a low carbon fuel standard. And that would mean that over the next 15 to 20 years, we will phase out the use of oil in the transportation, much of it in the transportation sector. That's what we should be doing. And and the cost of that means that our cost of moving people and goods, I use the same kind of sources as Yuri would be using, isn't more than 10 to 15%. So it doesn't show up as the doodads we buy or even the food being more expensive by more than 1%. It's not the thing that's going to cause great harm. And so that's what we ought to be doing. And then likewise, I'm really happy the federal government said we're going to phase out coal plants. And it's also put in, it's going to copy and intensify a policy Alberta's done called output-based pricing system. The details don't matter. That's in the electricity sector. So I think so Ontario's emissions already fell. So I guess you're aware of that. Quebec's have been falling. And now we need the whole country to be falling. Alberta will be falling less. I would not agree. Any modeling I've seen and that I've published and contributed to shows you that in 1.5 or 2C, you're not expanding oil sands production. It doesn't mean job losses. It means you'll still produce oil sands over the next 10, 20, 30 years, but you won't build more pipelines. And so you don't have to go into this narrative that people like, oh, you're going to kill jobs in Alberta. No, but you're not going to have more people moving into Alberta to get jobs that makes them more dependent and makes it all more difficult, the crash that they will eventually see as China, starting with its large cities, then India, move to electric vehicles and some biofuels. Did you want to add to that?
Yeah, I have a... Okay, I would like, there is a question online. Does the modeling account for aerosol masking? If emissions were from 2020, how much warming would we see?
Yeah, so the modeling in the scenarios that I present does account for aerosol masking and does account for the fact that currently we do not see the full extent of the warming that is caused by CO2. That is one of the main reasons that in the graph that I showed of what the remaining carbon budget would be, remember the small diagram with the red part, the blue part, and then what remains for carbon dioxide on top, that actually CO2 emissions, although they go down a lot, the warming of it is anticipated to increase. This is because some of the non-CO2 forces that we put in the atmosphere are currently cooling. But we also remove those from the atmosphere because we want to have clean air. These are sulfates that we remove from the atmosphere because we want to clean up our air. And so they bring also other benefits. So it's not something that we want to try to avoid, but it's definitely taken into account in the calculations.
Hi, I'm a member of the Vancouver Eco Socialists, and therefore I am one of those people who thinks getting rid of capitalism is a good idea. However, I'm not interested in having a back and forth on jargon. So let's just say we have an economic and social system and political system, which is a word that doesn't get mentioned very much in this discussion tonight so far, that is based on so-called market forces, which are reputed to be more efficient. I think that having gotten to the edge of a planetary disaster after 40 years of discussing it in the press and with the people that run the society and run the economy and stuff like that, shows a certain inefficiency. Not to mention things like what happened in 2008, where a huge amount of inefficiency required intervention by public funding through governments to bail them out. So I would suggest that maybe what we want to be talking about at some point is, and I have no idea what scale or what range we should be doing this, but is planning. I mean, a lot of what's been said here tonight is talking about planning, but the words aren't being used. Social planning. We should be, the people who are sitting in this room and our neighbors, not just going and talking to our neighbors about what we should do and about one policy or something, but we should be having community-centered discussions all the time about all the things that we talked about tonight, many of which I don't understand, and I'm sure that's true of a lot of people, but we should be able to start understanding that so that when we're asked to do stuff, when we're talking about what needs to be done, we're part of the planning process. We have to be part of the planning process. We can't just say, okay, you know, the two guys in the front of the room and some experts should go off and do this, and the rest of us should sit back and trust them to pull us out of the fire. We're going to have to do this ourselves, and we're going to have to do it without a market to keep track of us.
Great, and there's nothing to stop anyone from doing that now. So you can go ahead and do that. Or you can even elect a government that'll do more planning, and that would be fine to do that as well. As someone who was in a lot of co-ops myself, I was struck once by Oscar Wilde's statement that the problem with socialism, it takes up too many evenings. But
So thanks so much for the talk and the discussion. It was really fabulous. I'm over here. You're looking for me. My question is for Yuri. So it seemed to me that there was a really large growth of BECCS, some of which you talked about, the bioenergy capture and storage, and also a large growth in nuclear. So I was wondering, have you seen the growth of these technologies anywhere commensurate with what would be required for 1.5, either on a national level or on an international level? Thanks.
Yeah, it's correct that in some of those pathways, BECCS is deployed very wide to a very widespread level, and also in some of those pathways, nuclear is deployed very strongly. However, what I also tried to highlight, or what the report tries to highlight by showing those 4 pathways, is that you can make choices. If you provide a model with a certain technology that has no social trade-offs, that is cost efficient, and you tell it you can use it as much as you want it, the model will use it. There is no constraint, and the model will happily use as much BECCS as is technically possible. Now, you can do exercises, or you can explore different scenarios into the future where you say, oh, but now I want to figure out how to do this thing without BECCS, without CCS, with less nuclear. And these options are also available. But they also need, and they need specific strategic decisions. And these decisions are made every day, actually, by decision makers, by politicians. And so they really require you to be in contact with your decision makers, and if you have a preference about that, to also voice that to your decision makers. Now, I would say that except for the rapid deployment of non-biomass renewables, so solar and wind, none of the developments actually that are modeled in those pathways are currently ongoing. So they would definitely still need additional measures, additional decisions to be implemented.
Hi, thanks for the lectures. I really liked them. They were interesting. You talked a little bit about policies to do with the transportation sectors, ZEV, et cetera. Can you touch a little bit on policies to do with energy sectors? So I'm thinking back to the graph that had like the amount of like solar and wind that would be needed for different pathways. So what would be some policies to do with that?
So in British Columbia, we put in January 2007, I remember it well, because I've been fighting for it for 11 years, we put in a zero emission electricity policy. And it immediately meant that you could not build a coal plant unless it had the best of carbon capture and storage with it, which would mean tiny amounts of emissions, and likewise natural gas. And what that meant is you would go to renewables. Now, and then we set up a competitive bidding market for that. Could the market have been better? Could we have had, and Yuri talked about regulatory constraints, such as for us in British Columbia, mountainous, you wouldn't know this, but it was all run of river is what won the competitions. Now we've got wind as well, and even bits of solar in the interior. But it was a policy that just ruled those ones out. So it was regulatory, so it was a regulation, but it was flexible because it didn't pick the outcome. Had we done a little more to control the effects of the run-of-river, we probably would have got more wind earlier on as well. And we got biomass as well. We, burning wood, a 50 megawatt plant, and another one, and we would have got more of those. In the United States today, 35 states have a renewable portfolio standard. It's similar to that policy. It requires a market share through competitive competition for renewables. And states can ramp up the stringency of that. And that's why even what happens at the federal level in the United States may not mean so much, because the combination of some of these policies with low natural gas prices is killing coal. And Obama tried to kill coal, but it's going anyway. California's use of that electricity policy is what's leading to all of those renewables in California and the decarbonization that's going on there. And there are similar policies in Europe and elsewhere. I don't mean to exclude other parts of the world, but certainly those are ones close to home.
Thank you.
Thank you. Even if we regulate successfully domestic emissions of carbon and succeed in relatively, is there any way that we might feasibly regulate air transport, international air transport emissions, and our oceanic trade vessels? I'm not talking about pleasure stuff.
I will start because I don't have the answer, so that can then be provided. But I just know that there are definitely options, and there are technologies by which the emissions of those sectors can be reduced. So your question was whether we can do it politically. So at least the solutions are there, and whether it politically can be done.
Very good tag team here, yeah. So, what some people are trying to do is get sort of a global price on carbon, on all the emissions everywhere. And I sort of consider that sort of a global economist's dream, or a naive economist's dream. What I tried to emphasize in my talk was degree of difficulty. Things that are traded across borders are more difficult. I can buy my jet fuel here instead of there. I've actually been asked to go to Sweden in the next month because there's, the government tried to put a tax on jet fuel, and now the government can't reform itself. There's no government there right now. They're trying to form a coalition government. So the Danes tried to put a tax on meat consumption, and that lasted 1 year. So, but that was a domestic thing, so that even has a better chance. What I'm getting at is that, oh my goodness, if we do electricity and transportation, so except it's harder with the cross-border transportation, if we do those, then what did we have that the Canadian government did after Paris, in the year after Paris, whichever that meeting was, is they said, let's start a global coal phase-out, no coal program. That's we call that a sector-specific effort to get a global agreement. That's what you need to do. We need to do that with steel, with cement, and with jet fuel. And there have been efforts to do that in the Europeans tried to lead efforts on international agreements on jet fuel. It's so difficult internationally because governments are changing all the time. So Paris, it was like, oh, they've all agreed, and then they were gone. I mean, I just looked at a photo from 2015 or early 16 in Vancouver when Trudeau had brought everyone together for the Pan-Canadian framework, and it was all, and I said to my students at the time, I said, see all those premiers walking down that hall, it was this photo, they'll be gone in a year or two. We'll still be here doing our work. And I just looked at the photo recently, and they're almost all gone. The premiers of Quebec, Ontario, British Columbia, Saskatchewan, soon Alberta, and so on.
Hi, my name is Jean Boucher. I'm at UBC. I'm a sociologist, and I do research in behavior and culture and identity and these types of things. I really appreciate your presentation, Yuri, especially at the end when you talked about institutions and culture, and you said you, as a scientist, couldn't check those boxes. And I know more recently, terms like sustainable consumption are being brought into these higher levels. And since World War II, we've been fed this consumer culture, and our identities are practically wrapped up in our cars and our things and our houses and these types of things. Some of the evidence I have is that the top 20% of income earners are actually emitting like half of. Are you seeing some way from the top down to sort of create a new idea of what human success should look like? You know, trying to contain the way we consume. I mean, we're still inundated with advertising from the latest items and these types of things. I know it's a hard question, but anyway, there you go.
Yeah, thank you very much for that question.
It was not to me.
Yeah. Okay, I have at least one hook that might save me here. I'm not a sociologist, so there's very little that I can say on how this can be achieved. But what you see in the literature that I look at, which is still a top-down literature, which is still a literature where you don't fundamentally change the rules of society or how society works. This is still a literature where the economic system expands. This is still, to some degree, a capitalistic systems in all those scenarios that I showed there. But even in those scenarios, there are ways to limit the energy, the products, or the land that we use, and this would already make a huge impact. I'm not an expert in knowing how to achieve or whether a change in society would be achievable, or whether that would have a better impact. But at least I know that there are societal changes that we can implement that would make a huge difference.
I mean, my point is simply force yourself to look at degree of difficulty and to sort through all of those things. So yes, push hard for all sorts of behavioral change. And in the 30 years I've been working on this, I haven't heard anything new about that. I've heard people say over and over again, we need to change our behavior. And I just say, let's try to make sure that we don't bet the fate of the planet on the ability to talk 90% of people on this planet into changing their behavior. So let's make sure the energy system is zero emission. And then but all the while we're doing that, yes, work on behavioral change. So even when you say to me, these are the emissions from, when someone says it to me, from this kind of consumption, or flying in airplanes, or eating meat, I can show you, and it's in his report, no, actually, we can make biojet fuel. And there are ways to do it that don't destroy entire rainforests, but you have to regulate that. But is that easier or harder than getting people not to fly anymore? And I don't know the answer to that, but that's something we should be trying on both of those counts and then see where we succeed first. But don't wait to do one while we still allow, where we don't go after the airplane industry, don't go after electricity, don't go after transportation.
Hi. I've attended dozens of presentations on this topic over the last year, and I want to thank you for tonight. I thought both your presentations were the best I've seen in terms of positive tone and educational content that I could share with others. So thank you. And I have two quick questions on that. One, I have many colleagues and friends who could not come tonight. Is there any way we can share? Is this being videoed, and can it be reshown? And are the slides available for sharing with others?
So it is recorded, and recording will be available in the next few days.
Okay. What about the slides?
Yes, for part of the recording.
Yeah.
But separately as well? Like,
sure.
Yeah?
Yeah, you can get my email at SFU. I send my slides
okay.
to anyone, and I send them in PowerPoint so that you can do what you want with them.
Okay. And my second question was your book. When does it come out?
6 months.
6 months. How many? Sorry? 6 months, did you say?
Yeah, 6 months.
6
We'll say
months,
that.
okay. And last question, there's a group called drawdown.org. Have you heard of it? They talk about 100 different ways to implement what you're proposing tonight. I'm just wondering what your thoughts are on that website, drawdown.org. Yeah.
Yeah, I know of that initiative. I also now know of a couple of other initiatives. For example, one with Bertrand Picard that just looks at combining a whole repository of potential measures and of potential solutions, try to understand them and try to make them available and implement them. And I think, yes, that is useful, as long as it's science-based. And at the same time, it's also clear that the technologies are there, but things are still not happening. That means that technology alone won't save it or won't do it. And so while it's really good from a technological point of view to have those lists, yeah, more is needed. And Mark has been talking to this about what is needed and how those technologies can then actually be deployed, or how we can make that they are actually deployed in reality.
Yeah, so I don't know as much about that. But one thing I worry about, I helped even, I did the analysis in the development of British Columbia's climate plan in 1989. I've done a lot of these. And there's a tendency to want to write long lists. And that's why the intent of my talk was to have very short lists. So I'm sort of, just as I am with consumption, I believe in less is more. And that there's a better chance for action when you zero in. So I understand the rationale and the need for that and how it can help some people, but I also see a potential negative side to it if it's long lists.
Thank you, gentlemen. A couple of comments, and you got some of your students here, and I read a brilliant essay that's supported by the Grantham Foundation, which you have been supporting. And Jeremy Grantham, for your students, I found this fascinating, The Race of Our Lives Revisited. Has anyone read that essay, white paper? Well, you can get it on Google. So maybe you read it, because you've been with the Grantham Foundation. So Jeremy Grantham is the CEO out of Massachusetts, but he has various businesses and so on in England. Secondly, last night at an IPCC conference in Vancouver, I said to a few of these people in the cluster groups, I said, listen, your IPCC volumes, who reads them? Young people today need to get the information reduced from 3,000 pages to maybe 200 pages. They all said yes, but we work for the IPCC. So I don't know if the UN can sponsor this with the IPCC to cut all that stuff out, which is great stuff. This is all science. But we need to bring it down to the college and high school level. And that's where I come from, because I write for the students. Okay, I'm retired now. Thirdly, 1.5 degrees, 2 degrees. Now, we have, the Arctic is really the banana belt of Canada. And that with positive feedback, which cannot be quantified, I don't care what research you can provide, this is not going to help us with 1.5. So we know what's happening. We're into the Anthropocene, and there's no returning. However, I agree that we need to decarbonize, and all the stuff that you mentioned, and what I got from last night's discussion and my reading. So thank you. I don't want to be long, but that's my little message. Thank you.
Okay, I'm going to read a question online.
Nastenka?
Oh, sorry.
There's a response to that, yeah.
Oh, yeah, but just before you answer, let's just, so do this question, sorry. What are the environmental consequences of a global shift to electrification, given the amount of mining that will be needed for battery tech and EVs? Yeah.
Yeah, good. I first speak to the first intervention that, about the outreach. And well, indeed, what the IPCC produces are large reports. And these are thousands of pages if you accumulate them. But these reports, they're summarized in first executive summaries per chapter, technical summaries per working group, then a summary for policymakers of a couple of 20 pages. So then it already becomes much more accessible. Now, again, some of that language might still be kind of impenetrable, and I'm actually really glad to say that in this assessment cycle, or in this cycle of reports, kind of the leadership of the IPCC really has put a lot of emphasis on further public outreach with graphic designers, with, for example, for the 1.5 degree report, there was a small video made with the key messages. And I think as students, I think the reports are, or graduate students, I think the reports should be accessible. But if you think about secondary school or high school students, I think there is also a task for broader society. I mean, we have science writers, we have academics as I am, and for example, I'm now writing an article for a journal called Frontiers for Young Minds, which is a journal where you write contributions, and your contribution is reviewed by 10 to 12-year-olds. And if they can't understand what you wrote in there, then it doesn't get published. Of course, this is not new research that we are publishing there, but this allows you to write articles that are scientifically correct, yet are understandable and can be used in primary schools and in secondary schools. So I think also there, this cannot be on the shoulders of the IPCC, but I think the IPCC is providing the scientific basis and the evidence for others to take over and do the outreach. You want to talk about the electrification?
Well, you go ahead, or I can do it. Yeah, all right, fine. So, I mean, if you look in Yuri's talk, even though I belittled energy efficiency a bit just because of my degree of difficulty analysis, the amount of reduction in energy use that we do, our success there can really help us with this energy transition. So, you know, obviously you don't have to make as much electricity if you're driving less, so you have less electricity that you need to move your transportation sector, to heat buildings, to run industry, and so on. And so what I can say is analyses that I've been involved in, and I wasn't on the last IPCC, but I was on this thing called the Global Energy Assessment that Yuri knows about. It was based out of his institute, the other institute just outside of Vienna. And so we did that. And again, it's a huge volume, but we did a summary for policymakers, and that's where you put all those numbers together. And you do have to be careful with that. So for example, there are people who are really optimistic about how little metal we need for, whether it's for batteries or for equipment, for wind turbines, and how easy this is. And I'll point out one scholar who's spoken here recently, I think, Mark Jacobson from Stanford University, his WWS Futures, wind, water, solar, where he limits it to just those things. So there's, and then that's a really electrified economy. I'm among a sort of a larger group of international scholars who see some problems with constraints on how he seems a little rose-colored in our view in terms of the cost of getting all of those materials and making that transition. And so there are those of us who are more open to if you still are using nuclear power somewhere and people are still willing to do that in a certain region, then that's fine. If the fossil fuels are very rich somewhere and you can do carbon capture and storage and so on. So I can't give precise numbers on that, but I'm saying that's very much part of the analysis that goes on, I'm assuming in the latest IPCC, but certainly the modelers that I know who are doing the same kind of thing, the Global Energy Assessment.
So my question is a feasibility question. So I think I also strongly agree that top-down solutions are the most comprehensive path to being able to make widespread change. And I've also seen a lot of research and documentation that discusses the huge impact, and what I've seen, perhaps might be wrong, but what I've seen is that the impact of our agriculture industry is almost at the same level as, if not the same level as, the energy sector. And what I've seen is that it's also particularly focused on meat products, whether that's deforestation impacts and the loss of forests from that, as well as just the amount of methane produced by cows, particularly. In my view, telling everyone to become a vegetarian isn't just not going to work. But what I think might be a lot more of a workable solution is using the top-down approach for food consumption. Essentially, so my thought is, and I've heard this elsewhere as well, if we remove subsidies for a lot of the meat industry, particularly dairy farming and meat. So my question for you guys is, for Yuri, the question is, do you think that this would make a significant impact on greenhouse gas emissions and climate change? And then for Mr. Jacquard, the question would be, do you think that this would be a feasible thing to put forth in BC and or the Canadian federal government? On what level of difficulty would one be facing to try and put this through?
Okay.
Okay, is this working good? My question was, I wanted your thoughts on the nutrient loss of soils to produce biofuels, and if we're not treating this as an externalized cost that we can ignore.
Okay, first on the diet and the dietary change, and whether that would make a big impact.
Not dietary change, but the removal of subsidies from the meat industry, so that so my thought is that if meat would become more expensive, then people would choose it less, and if meat became less you could make less money by selling and producing meat, then there's less of an incentive on meat farmers to produce meat, to sell meat. So they might, instead of having a beef farm, they might have a corn farm or something that might be be able to feed as many people or around the same amount of people, but wouldn't have quite as strong of an economic impact. So not diet change necessarily, but I suppose, well, for you, the question will be the reduction of consumption of meat and other, high impact agricultural industries.
Okay. To the first part of your question, unfortunately, I don't really have an answer of whether that would, just because I don't know. Logically, yes, it would, but I don't know how much and what really the effect would be on the actual greenhouse gases ultimately. But it is clear that reductions in greenhouse gas intensive food products are part of also the scenarios that I showed. And if you remember the 4 scenarios that I showed, the 2 on the top, the P1 and P2, they both assume what in these scenarios is termed sustainable diets. So that's not just meat reduction, consumption of meat reduction, but also a general shift to a balanced diet, whereas in many parts of the developed world we actually have overconsumption and problems of obesity. So those scenarios also assume that. On the nutrient loss, yes, that is definitely one of the key feasibility issues that I tried to allude to on my slide, where I said there is a lot of carbon dioxide removal, but there are feasibility and sustainability concerns, and one of them is the nutrient loss, is the requirement for water for irrigation, land, and then many other social aspects of where land is needed and land is required in areas or in environments with not so much social protection. There can be really societal impacts of any measures that require loss of land.
I have just, first of all, one comment, and I went through this really fast in my slide, but the people who do these total system models, even globally, mine is, I do models for individual countries. People will say to us, well, cities account for this much emissions, or buildings account for this much emissions, or food accounts for this much emissions. And what they've done is what we call a static analysis. They've worked their way through, how was the trucks that were running, and how were the buildings done, or how was electricity made? And of course, we have to look at where society is trying to push. I've tried to limit it down to a couple of sectors that we really focus on while pushing everywhere else. And what happens is, when you do that, you actually can end up where the emissions from agriculture, at least from agricultural machinery, from fertilization and so on, are far lower than what we have today. The second point I want to make on that, which relates to the question about biofuels and nutrient, which again is also not my expertise, but I make sure I constrain and say, let's go at the literature of the people who looked at this, is to beware of all or nothing solutions where someone says, oh, we're going to replace all transport with biofuels. Oh my goodness, look what that means for rainforests and food production everywhere. Instead of saying, no, we're going to constrain these things, but let's not rule them out. And what happens is, as you constrain them, so the Norwegians right now are in a dispute with Malaysia whether their palm oil production is done sustainably or not. And those are normal disputes to have, because then it forces the Malaysians to try to make sure they can get, and they've already shown they've got areas where they are compliant. And so, but the all or nothing says, let's take all of the demand for transport, whereas in fact, one can argue that even though the amount of mobility of humans increases, that the efficiency gains reduce that by the demand for energy by 25%, more so in a developed country, even more than that, and that electricity becomes a very important fuel, and in some cases hydrogen, in some cases fuels from direct air capture possibly, but also in some cases biofuels done in ways that, yes, have some food cost impacts, yes, have some land use impacts, but are not in the sort of all or nothing devastating manner. So we need to regulate things, but I just don't rule out some of that possibility. We're already seeing it in some cases. And that's the same thing that I do say, though, is, when you're saying, let's have this, here's something that might be really beneficial, all I invite everyone to do, so you're saying a dietary change, is figure out how government makes that happen. How do we elect the government that would make that happen? And then once that government's in place, what policies would they put in? So you must have already heard me. I said, okay, Denmark wanted to make that happen, tried to put a price on to make up for whatever subsidies there are in agriculture, presumably, and it backfired politically. You couldn't elect those people. They have been able to elect people that are going to get their electricity system down to zero emissions. They are now starting to follow the Norwegians and move fast in transportation. So that's all I'm saying. Go ahead and push for these other things, but and go ahead and try to get a government does that. And all I'm just pointing out is fine, but let's like really push hard. The things we know we can do, make sure governments do that, because there's no excuse on something like that. And that's when our governments have to push right around the planet.
But will they be effective? I mean, we have a climate emergency. It's fine picking the easy things, but maybe it's, you know, we have to look at the whole picture.
Okay, pick the hard ones.
Okay, so we have to close our discussion here, so we're over time already. So let's thank our speakers. And so today we explored the question of what it takes to limit warming to 1.5 degrees, and in the talk in February we'll be looking at why it is worth it. So we hope to see many of you there on February 28th. Thank you.